In the quiz for today, we're going to focus on compressive stress, and we'll do that with a couple of problems. The first one is this brick and concrete garage. So I adapted the problem that was in our book. Here's what the original problem said, one of these story problem things. So these two walls, there's their size, there's the concrete roof size. Roof weighs this, snow weighs this. Check the compressive stress at the base of the wall, assuming the brick has a capacity of 125 psi and brick weighs 120 pounds per cubic foot. Let's break that down. We can make that more digestible. So we will start looking at the total roof load in the first question. All right. So we've got a roof that weighs 100 pounds per square foot, so that's the dead load. It carries a snow load of 30 pounds per square foot, so that's the live load. What do those add up to for the total load on the roof? 100 plus 30 gives us 130 pounds per square foot. So each one of these square feet of concrete roof is holding up 130 pounds. And let's find out how much this total roof weighs. Now you will notice that in the picture in the book, he doesn't tell us how long this building is. He tells us it's 20 feet wide, but there's a missing dimension here. And that's because we're just concerned with what's happening on a square inch or what's happening on a square foot. And every one of the square inches or square feet is exactly the same. So we can make our lives simpler by just thinking about a typical 1 foot long strip of building. That's what we'll do here. So you figured out that the total load with the dead load and the live load was 130 pounds on each square foot. How many square feet do we have? We have 1 foot long by 20 feet wide. We must have 20 square feet. So how do we find the total load sitting on that roof? We've got 130 pounds per square foot, and we have 20 square feet. 130 times 20. Those square feet cancel out, and so we have 130 pounds times 20. That will give us something, 2,600 pounds. Now we're supposed to be thinking about what's happening on the bottom of a brick wall, so we need to think about how there's only half of that roof load on one wall and half of that roof load on the other wall. So how much load is on each wall? Half of that 2,600 pounds. That was 1,300 pounds. Now we need to think about not only how much does that roof weigh, but how much does the brick wall itself weigh? And he told us how much it weighs per cubic foot. So first we're going to need to figure out how many cubic feet are there in this 1 foot length of wall. All right. So we've got a brick wall that's 12 feet high and it's 4 inches wide. How many feet is 4 inches? Well, 4 inches is not a whole foot. There are 12 inches in a foot, so let's go 4 divided by 12 inches in a foot. The inches cancel out. 4 divided by 12 is 1/3 of a foot. Okay, so this wall is 1/3 of a foot wide and 1 foot long and 12 feet high. So what's 1/3 times 1 times 12? How many cubic feet is that? now the brick weighs 120 pounds per cubic foot. And now we want to find out how much does the wall weigh. So it weighs 120 pounds per cubic foot. And in the previous step, hopefully you figured out that you have 4 cubic feet of brick here. 120 pounds per cubic foot times 4 cubic feet. The cubic feet can cancel out. So you have 120 pounds times 4. That will give you, how many pounds is that? 120 times 4 should be 480 pounds. That's what the wall weighs. And in an earlier step, you figured out that this half a roof here weighs 1,300 pounds. So the total weight sitting on the bottom of your brick wall must be, what? 1,300 plus 480. It must weigh 1,780 pounds down there at the bottom of that brick wall. Now let's find the stress in PSI. He tells us what the allowable stress is in PSI, pounds per square inch. So we're going to have to start thinking in square inches now. No problem. We know that this wall is 4 inches wide, and we're analyzing a typical 1 foot long strip, in other words, a 12-inch long strip. So how many square inches are there in that strip of wall? 12 times 4 must be 48 square inches down there at the bottom. Alrighty, now we're all set up to figure out the stress. So you just figured out that the weight of this whole roof plus wall thing was 1,780 pounds. And you just figured out that the area at the bottom of that wall was 48 square inches. You're all set up to figure out the stress now. With our good old familiar stress equation, stress equals force over area. So force, 1,780, over area, 48. You should get just a little bit over 37 psi. It's something like 37.083 psi at the bottom of the wall. That's not the answer, though, because at least in our book, he says, check the stress at the bottom of the wall. Okay, so what he means is, he tells us that the allowable stress for this brick is 125 psi. What you just figured out was that the stress, the actual stress, is a little over 37 psi. So the question is this brick strong enough to hold up this concrete, the snow load, and the brick wall? And the answer is, yes, it is. How do we know that? A little over 37 psi is less than the allowable stress of 125 psi. Therefore, it's okay. And this 3 dots thing arranged in a triangle is the logic symbol that stands for therefore. Many engineers use these 3 dots to represent therefore. Many engineers do not. I like the 3 dots, so I have written, therefore, it's okay.